In this video, we're going to discuss the y-intercept of exponential functions. Let's look at an example. Let's say we have an exponential function y is equal to 3,000 times 1.01 to the x. And we want to know what is the y-intercept of this function. Whenever we're solving for the y-intercept of a function, we set x equal to 0 because wherever a graph crosses the y-axis, the x-coordinate is going to be 0. The x-coordinate of that point is going to be 0. So we're going to do y is equal to 3,000 times 1.01 to the 0. And then we're going to solve this for y, which is the y-intercept. 3,000 times 1.01 to the 0 is just 1, so it's 3,000 times 1, which is just 3,000. So y is equal to 3,000. Let's look at another equation. Let's say we have y is equal to 3,000 times 1.07 to the x, and we want to find the y-intercept. So we're going to set x equal to 0. Y is equal to 3,000 times 1.07 to the 0. Y is equal to 3,000 times 1.07 to 0 is just 1. 3,000 times 1 is just 3,000. Notice that whatever we have in the parentheses, it doesn't matter whatever we have in the parentheses. We're always going to get there. Our y-intercept is going to be this number before the parentheses. So if we have our exponential growth or decay function, a is equal to p times 1 plus r to the t for exponential growth, or p times 1 minus r to the t for exponential decay. Since we're setting this t value, this x value equal to 0, whatever is in this parentheses is automatically becoming 1. So we always have a is equal to p for the y-intercept, and p we know is the principal, or the original amount. Therefore, the y-intercept of any exponential function always represents the original amount of that function. For example, if you have money in a bank, the y-intercept is the original money in the amount of money in the bank. If you have bacteria in a dish, p, the principal amount, is the y-intercept, the original amount of bacteria on the dish. Let's look at an example. This is question number 15 from the January 2015 Algebra 1 Regent. Some banks charge a fee on savings accounts that are left inactive for an extended period of time. The equation y is equal to 5,000 times 0.98 to the x represents the value y of one account that was left inactive for a period of x years. What is the y-intercept of this equation, and what does it represent? So we know that in order to find the y-intercept of any function, we're going to set x equal to 0. So we have y is equal to 5,000 times 0.98 to the x, or we're setting x equal to 0. Then the 0.98 to the 0 becomes 1. So we have y is equal to 5,000 times 1, and y is equal to 5,000. And that's what we assumed because we know that always the number before the parentheses is going to be your y-intercept. And the number before the parentheses in an exponential growth or decay function, a is equal to p times 1 plus or minus r to the t. P is always the number before the parentheses. It's always the principal or the original amount. So the answer to this question is choice number 3. The y-intercept is 5,000. 5,000 represents the amount of money in the account initially.